So I'm Brenden Smith. We are at the Center for Regenerative Medicine here at Boston University, and I work on megakaryocyte differentiation, so a specific type of blood cell that makes platelets. So I'm actually from Warwick, Rhode Island. I'm very close to here. Science was never my strongest subject growing up. I really liked English and history and things, and going into college I knew I really liked psychology and behavior. I really liked that aspect of science, and what I found out was that there was a neurobiology, this underpinning of what happens, and I was really interested in that. Not the behavior itself, but why human beings undergo that type of behavior. There's neural circuitry, there's learning and memory, there's addiction centers in our brain, there's all these things, and that's what really attracted me to science, because it's really the molecular understanding of what we do and everything basically in our world. So from there, I really love the idea that learning, memory, behavior, all these things had a neural circuitry going on. So the idea that there was molecular mechanisms at play was very interesting. So I work with the megakaryocyte, which is this really cool type of cell that's in the blood, and it's actually in the bone marrow. It's a very large cell, and it undergoes a process known as endomitosis. What I'm working on is ultimately not only trying to understand how the megakaryocyte is formed in our body, but to exploit this information in order to make as many megakaryocytes and thus platelets as possible in a tissue culture dish. There's a lot of efforts now to make large amounts of platelets that can actually be used for platelet transfusions to be put into patients. So we've all heard of platelet donations. So that's when you're not only just giving your blood, but they're actually putting your blood through a filtration process, and it takes longer, and they actually collect your platelets. This is for specific reasons. There's people out there that need platelet transfusions, and so there's a large effort now, both on the academic side of things as well as in startup companies, to make large amount of platelets that we can prove are functional and will be safe in patients. So I use induced pluripotent stem cells. So what they are they're stem cells that we can create from adult cells from any person. So essentially we can take a person's blood or a little bit of their skin, and we can actually, in the lab, turn them into stem cells like they would be in an embryo. Cells that essentially can make any type of cell type in the body. So here at the CREM, people do this in order to make lung, in order to make thyroid cells, and in our lab to make various types of blood cells. The type of blood cell that I try to make is the megakaryocyte. And in making this cell from the stem cell, I can sort of have development in a dish where I can see the path from the stem cell all the way through to blood specification and then to megakaryocyte specification. See how this cell becomes the megakaryocyte in a way that's unprecedented, right? Because you can do this in a dish in a very ethical way and with an unlimited supply of cells.
Yeah, that's usually what I see, like when we do these organ cultures, like that.
Well, I think there's a lot of potential right now. It's a very exciting time to be working in regenerative medicine, because the stage that we're at now at the CREM is for trying to find ways to treat diseases. So maybe that's from making cells that we can then do screens with thousands of compounds to see which compound is going to do the best to make this cell a healthy cell, for example. And so the potential for genome editing in the context of stem cells is really quite remarkable. It's almost science fiction, really. We're basically proofreading the genome so that it won't have all these nasty genes that causes disorders down the line. And so right now we're really trying to optimize way to treat pre-existing disease. Later, with genome editing strategies, the hope would be to actually prevent disease. But that still is science fiction. But many things that once were science fiction are now science fact. You know, I think for high school aged kids, what you really want to hone in on is if you like science, then that's a fantastic foundation. And what you have to realize is that when you're doing your chemistry lab or you're dissecting the frog and your teacher is telling you exactly what to do in order to get to the end of that experiment, that's so that you have the foundations. But once you get to this level, you create everything. It's you who decides your path in what you are trying to accomplish and ultimately what you're trying to give to the scientific community through your work. So if you want to have a profession that is particularly creative and allows you to really think on your feet and to approach problems in a very novel way, this would be the path you want to go down.